Hello guys, today we will learn how to find the limit as x approach infinity and negative infinity for irrationals. Okay, first of all, let's start with the function 1 over x. Let's try to look at the shape of this function, the graph of the function. Okay, I'm going to ask you a question. By looking at the graph, what is the limit as x approach 0 from the right side? Well, as x approaches 0 from the right side, is equal to the infinity because the function is growing, as you can see. And if you look at the limit as x approaches 0 from the left side, the function is decreasing and going to negative infinity, right? Now, we're talking today about the limit as x approach infinity and negative infinity. Okay, let's go through this. What about if I want you to tell the limit as x approach positive infinity for the function 1 over x? Well, if the x's are growing, the function was decreasing, almost touching the 0. That's going to be 0. So 1, if I want to plug infinity, now we cannot plug infinity. It's not practical, but it will help. When you plug infinity, you're going to get 1 over infinity. That's equal to 0. And if you try to find the limit for 1 over x as x approach negative infinity, by looking at the graph here, you will notice that as x values decreasing, the y values were almost touching this line here, which is 0. If I have an infinity, positive or negative infinity, over a number divided by any number, like 7,000, whatever you want, the answer will be positive or negative infinity because infinity is too big, in which if you divide it by any number, it's still going to be infinity. Where if you have the other way around, if you have a number divided by infinity, and that's going to end up 0, okay? Now let's try to use the formal way. Well, the formal way says if the limit as x approach infinity, we're going to divide each term in the numerator and the denominator by the leading variable here, which is x squared. So now I'm going to divide 3x by x squared plus 7 over x squared over x squared, 2 over x squared. That's going to be equal to the limit as x approach infinity, 3 over x, 7 over x squared, 1, 2 over x. Now I just told you that any number divided by infinity will get 0. 7 over infinity squared is 0, and this is going to be 0. In the numerator will stay 0, the denominator 1, and that's equal to 0. Now if you try to change infinity by positive infinity, actually we are going to get the same because 3 divided by negative infinity is 0, and we are going to get the same. Okay, so positive or negative infinity will end up the same answer. Same here. Now we know that the answer should be 0 because the degree of the numerator is less than the degree of the denominator. So we need to do it in a formal way. So we are dividing each term in the numerator by the x to the power of 6. And that's going to be equal to the limit as x approach positive or negative infinity. Simplifying this, over 1. And now by trying to plug infinity, we're going to get 10 divided by infinity or negative infinity, 0, 0, and 0, and that's going to be 0 over 1, which is equal to 0. Now, what about if the degree of the numerator equal the degree of the denominator? Well, the non-formal way says if the limit as x approach positive or negative infinity here, we're dividing the leading term divided by the leading term. That's going to be limit 2 over 5 as x approach positive or negative infinity. Well, it's a constant, so we'll stay 2 over 5. But we need to do the formal algebraic method, which is limit as x approach infinity. You're dividing 2x divided by x. Okay, and by putting this in a simplest form, substitute x by infinity. This is going to be 0, 0. That's going to be 2 over 5. Now, as you notice, if it is positive or negative infinity, will stay the same. Now here, we can decide right away the answer. As we can see, the degree of the numerator equal the degree of the denominator, x cubed and x cubed. The leading coefficient here is 2, the leading coefficient here is 1, so the answer will be 2. But we need to do it in a formal algebraic method. So the limit as x approach positive or negative infinity, 2x cubed over x cubed plus 7 over x cubed. Same with the denominator. Now simplifying, substituting by infinity, this is going to be 0, 0, 0, and 0, and the answer will be 2 over 1, which is 2. Now, what about if the degree of the numerator is greater than the denominator? Well, if I try the non-official way, it says limit as x approach to positive infinity will be x cubed over x squared. That's equal to x. Okay, so the limit as x approach infinity of x, substituting x by infinity, that's infinity. And if you try the limit as x approach negative infinity, and that's going to be negative infinity, right? Now, how we are going to show this in a formal algebraic method? We're going to do the same thing we learned before. Dividing everything by x squared. Okay, so x cubed over x squared simplifying. Now substituting by infinity, that's going to be 0, 0, and 0. What is left? Infinity plus 7 over 1. That infinity plus 7 is infinity, divided by 1 is infinity. Now if we will put, we'll make it negative, then that's going to end up negative infinity here, and that's going to make it negative infinity. So let's change this. If I put negative, negative, the difference will come here, and that's it. Now again here, Think about it. What is the answer? Well, you need to compare the degree of the numerator by the denominator. If the numerator greater than the denominator, the degree, okay, then the limit will be either positive or negative infinity. Now, let's try that. So we know that it's going to be positive or negative infinity. So limit as x approach infinity, dividing the numerator and denominator by x cubed, right? Simplifying, substituting by infinity, this is going to be 0, 0, 0, and 0. The answer, the last thing will be limit as x approach infinity, 3x4 over 6. That's going to be limit x approach infinity, x4 over 2. Well, if you substitute by infinity, infinity to the power of 4 is infinity, which is equal to infinity. Now, what about if you try to substitute by negative infinity? Well, if you try to substitute by negative infinity here, this part here, okay, we're going to get limit as x approach negative infinity of x4 over 2. By substituting x by negative infinity will be negative 1 to the power of 4 is 1. So that's going to be infinity to the power of 4 over 2. And that's also going to end up with infinity. Okay, guys. We're done for today. Thank you for watching. See you. Bye.